prosthetic arms particularly, most of the research has been very focused on making sure that they perform well, because they're currently not performing very well. But what people don't seem to be looking at very much is the fact that there's a lot of discomfort. So for prosthetic legs, you're putting all your weight on the limb all the time. So it's been known for a very long time that there are issues with comfort there, and they need to look at that. But surveys have shown that comfort is the main dissatisfaction area for upper limb prosthetics users as well. Above things like performance or aesthetics or ease of use, they're really finding these prosthetics that they're wearing uncomfortable. So first I'll go into a little bit of the cool stuff that's happening as far as functionality. A few years ago, they've managed to neurally connect prosthetics so that they do surgical removal of the neurons that were controlling the hand before the amputation, put them into the chest so that the chest muscle contracts. When they think about moving the thumb area of that muscle contracts, and you can get a sensor over it, which then controls the hand. This one is from the University of Utah. They've managed to go even further than that now, and they've made an array that can directly connect into the neurons in the remaining limb, and they've been testing that with a virtual prosthetic. So soon enough, we'll be able to actually control that with our brain. Stanford University have managed to make a skin that can test pressure and temperature, so you can start to feel again in your prosthetic hand. At the moment, they've got the electronic signals coming out of that, and they're still trying to work out ways that you can then connect that into the brain. But despite these fascinating new technologies that are coming out, most of this state-of-the-art stuff is not affordable to your everyday amputee. And even with them, the hand is still a long way off functioning like an original hand. So what I'm looking at is the rejection rates of prosthetics. A lot of amputees will not use their prosthetic because it's too uncomfortable, so it would need to have a huge amount of functionality to be worth their effort to go and wear it. So amputees who have one amputated arm typically can do about 90% of everyday tasks without using a prosthetic. So this extra functionality is of great benefit to them for independence, but it's not necessary for a lot of their tasks. So we really do need to start looking at how you improve the comfort so it's worth them becoming fully independent and making the time to learn these new devices. So if we look at what's causing discomfort, now that we know that it is an issue, we need to start looking at what area is the discomfort. And there's all sorts of things that could be causing that, like the weight of the limb, or whether they're sweating, phantom limb pain. But what I'm particularly looking at is the device user interface. So what's going on between the prosthetic and the arm that's remaining. So these kind of things are the sensory aspects, so the pressure, the humidity, so as it starts to sweat, what happens to the limb and the comfort, what happens when you've got friction forming there, and temperature changes at different parts of the limb. So when you're fitting a limb, it is very important to get the right kind of shape to make it comfortable, because everyone's limb is individual. It changes quite dramatically between things. So we first want to see what is happening there, whether these changes are occurring in things like the local temperature when you're using your limb, and then whether that's actually connected to the pain that they're feeling. So just because someone's got changes occurring there, do they map directly to how they're feeling as far as the severity of the pain, the type of pain that they're experiencing, and the location of that pain? If we can find that there are objective ways of measuring this pain, so that we don't just have to say, so is it painful? How painful is it? We can start to predict what kinds of things, do some basic skin sensitivity tests, and try to predict what kind of socket they might need to make it comfortable for them. But more than that, we can start to look at whole populations, and if we're finding that sweating is the major issue across the whole population, we can start to redesign sockets more generally to be more focused on aerodynamics and making sure that there's airflow coming through. So things like that as kind of where we're going as far as objectively measuring what's going on in the prosthetic limb. The two main ways that they can make the sockets currently, mainly, is using this plaster casting. So this method has been around forever, and it's still the main one used in the world to get the shape of the limb. You plaster cast it, then you create a mold around that, and then you make the socket around that. You can also go into 3D scanning these days, which is coming out more and more commonly. But even both of these, you need the prosthetist to have quite a lot of knowledge to know where to put the pressure so that it holds on, so that it grips firmly, doesn't slip, and still distributes the pressure so it's not going to be painful. So what we're finding is that the World Health Organization reckons that there is a shortage of about 40,000 prosthetists across the globe, which means that there isn't that expertise out there in most rural and remote locations. So how do we get people out in these regions to have access to the equipment to make the prosthetics and the expertise to be able to actually use that? And if we can start to look at objective measures of comfort that we can then program into software, then some of that on-the-ground expertise may not be quite so necessary. 3D printing has come out as a recent advancement which looks really, really promising for one-off products. So it's a great way of being able to get local manufacturing happening for individual customized things. But the issue with this kind of thing is that there's all sorts of groups who are going out there, they're producing hands, they're putting them out into the community, they're allowing free access to this technology, which is amazing for reducing the costs. But the issue with it is that they haven't actually validated any of this technology. They're just putting their designs out there, and there's no regulatory structures in place to look at what kind of harm this might be doing as far as compensatory movements and things like that. MIT have gone to the other end. They're doing very, very fancy stuff with their 3D printing of sockets, putting in some of those objective measures. So they take an MRI and they look at where the bone is near the surface, and then they 3D print on a multi-material printer, which means that you get cushioned areas anywhere where the bone is near the surface and you get harder areas elsewhere. But both these technologies are very expensive again. So we're trying to look at how you objectively do that, but without using quite such expensive equipment. So firstly, I'm looking at whether or not 3D printing might be an option for these remote and rural communities. And secondly, whether there are objective measures that you can find at the device user interface that might be able to predict what kind of socket is going to best suit these users for comfort, so that we can get more accessible equipment and lower cost, as well as being comfortable. So the question is, how does that actually benefit Australia? And the answer to that is that, again, a bit like Lauren said, there's a lot of rural and remote locations in Australia where it's very, very hard to get specialist prosthetists out into these regions. So at the moment, an amputee who is perhaps a farmer who has injured themselves on farming equipment would have to spend weeks off the job coming into the city to be fitted with a new device because the manufacturing process is very long and complex, and then they have to get refitted and adjusted to make sure that it's comfortable before they go back out. So if we can do that via maybe a Skype consultation with a local 3D printer, it would be hugely beneficial for reducing costs. Thank you.